Welcome you all students. I come up with a question from principal moment of inertia. Find the principal moment of inertia of the plane area about centroidal axis. So this is the L section which is given for us to identify the principal moment of inertia, right? So when you are having the principal moment of inertia, almost we have to identify all the answers like centroid, then moment of inertia, product of inertia, then the location of principal axis, and at last only we can able to identify the principal moment of inertia, because the principal moment of inertia include all the things, right? Fine. So here to find principal moment of inertia, I max and I minimum, right? This is we need to find. Okay, solution part. First start with the location of centroid. Location of centroid. This is the first step. Okay, so for that already it is given in the diagram. Okay, here what we have to do is the coordinate is ready, but we need to split down into simple shapes. Okay, so this is the L section. I just going to simplify just like this. Okay, if I divide it in, I can say this is one rectangle and this is the another rectangle, so that I can say this is the first part and this is the second component. Fine. So let us start with the first component, 1, which is a rectangle, and just we can identify the self-centroid. So I just going to draw the diagram of it. I just going to position exactly where it is in the previous. So this is the length with centimeter, 4 mm, 4 centimeter, and here it is with 1 centimeter width, right? So I just want to identify the centroid. Okay, so here x1 and y1 we need to find. x1 and the y1 we need to find, right? So x1, it is from the O, x is just from the O. Directly put this self-centroid formula. Rectangle in the sense length divided by 2. So b divided by 2. Here we get 4 divided by 2. The answer will be 2 centimeter. Okay, 2 centimeter. And then move to the next one, y1. So here the object is just from O. Okay, it is beginning from O, there is no gap, so directly put this self-centroid formula. Self-centroid for the rectangle is h divided by 2 in order to find the y. So here the h, that is width, is given as 1 divided by 2, we get 0.5 centimeter. Okay, 0.5 centimeter. And then area A1, I can say it's A1. So area of rectangle is nothing but length into breadth, BH. Length is 4 and breadth is 1. So we get 4 centimeter square, right? Move to the second component in order to specify the centroid. So second component as well, it's a rectangle. So raise it, rectangle. I just going to place the component of second in the HY coordinate, the same place. Okay, this is the second component. Its width is 1 centimeter, length is 1 centimeter, and what about the width? Width I can say up to this is 4 centimeter, because the entire length here it is mentioned as 5 centimeter. This thickness is 1 centimeter, so 5 minus 1 we get 4. This would be the 4 centimeter. 4 centimeter. What about the gap between this OX coordinate or axis? It will be 1 centimeter, the thickness of this ray. Okay, so this is Y. So now identify X2 and Y2. It's a centroid. So X2, this is the X2, and Y2, it's from O, so this is the Y2. So this one we are going to find it out. So X2 is equal to, it is just beginning from O, so self-centroid, length B divided by 2, so that B is 1, so 2 divided by 2 in the sense 0.5 centimeter. Okay, 0.5 centimeter. And what about the Y2? Just see here, it is not from O, somewhat far from this OX. Am I right? OX, it is somewhat far from. That gap is 1 centimeter, so add 1 plus its self-centroid. O to this distance, so plus this self-centroid. So self-centroid for the rectangle is Y is equal to H divided by 2. So here comes 1 plus H is 4. 4 divided by 2, we get 3 centimeter. Can you get it? 3 centimeter. And A2, area of the rectangle in this second component. Okay, so it's nothing but B into H. So here B is 1 and H is 4. We get 4 centimeter square. Right? So if you want to plot it out, I can say this is how the result will be for plotting down the centroid. So this is how the L section is, and this is the axis X, Y. Okay, let it be. Now see, we need to identify for the total. Here we have two components, right? So X bar and Y bar we need to find. That means the first moment of area. So here comes two components. So A1 X1 plus A2 X2 divided by total area. So A1 plus A2. What would be the answer here? A1 is 4, X1 is 2 plus A2 is 4 and X2 which is 0.5 divided by A1 plus A2. So 4 plus 4, here we get the answer as X bar is equal to 1.25 centimeter. Similarly, identify for the Y bar, so that we can plot the centroid for this compound shape, L shape. Okay, so here the first moment of area about YY axis. So here it will be A1 Y1 plus A2 Y2 divided by total area A1 plus A2. So what would be the thing here? 4 into Y1 value is 0.5 plus here Y2 value is 3, so area is 4, so 4 into 3 divided by A1 plus A2, here 4 plus 4. Just we will get the Y bar as 1.75 centimeter. When you do the calculation, we get 1.75 centimeter as the answer. So just plot it down the centroid. So X bar is 1.25. The entire length is 4 and this measurement is 1 centimeter. Okay, so somewhere here the X measurement is, so here is the X bar. Okay, what about the Y bar? Y bar is 1.75. The entire, this height is 1 centimeter, so somewhere there the axis will be. So this measurement is for Y bar. So this is the point, we call it as centroid C. Okay, what is next? What is the next step? After identifying the location of centroid, we must identify the moment of inertia for the L-shaped structure. Okay, for that, let me write down moment of inertia. The next step is moment of inertia. So here we are going to identify the moment of inertia for the total section. So I can say Ixx, moment of inertia about xx axis, which is equal to Ixx1. Here we have two components, so Ixx1 plus Ixx2, right? So here first of all we can identify Ixx1 and Ixx2. Ixx1. So if I elaborate it, it's self moment of inertia Igx, okay, the self moment of inertia plus area into perpendicular distance square. So here h1, it's a first component, h1 bar the whole square, right? Here as well the area 1. Okay, so here Igx for the rectangle. Here see, for the rectangle shape, the moment of inertia is bh cube divided by 12, and Igy it is bh cube divided by 12. Okay, here it is bh cube divided by 12, and here it is hb cube divided by 12. So here it's for x, so it will be bh cube divided by 12 plus area formula. Area value is for A1 it is 4, so directly we can put 4 into h1 in the sense the self-centered of the component and the centroid distance. So for the first component, somewhere here it will be the centroid, approximately here. So this distance is nothing but h1. Okay, this distance is a h1. So that distance we are going to calculate. So here it will be y1 minus y bar. Okay, this distance is y1 minus y bar. Okay, fine. If I do the substitution, breadth of the first component is, that means length of the first component is 4 and thickness is 1, so divided by 12, here cube, plus 4 into y1 value is 0.5 and y bar value which is 1.75 the whole square. The total answer we get as like I can say, when you are doing the calculation, you will get 6.58 centimeter per 4 moment of inertia the first component, and moment of inertia in the second component in the x direction can be calculated Igx2. Okay, that's 1. This one is Igx2 plus A2 into h1 the whole power. So here comes the formula will be, it's for x, so bh cube divided by 12 plus area here, area 2 which is 4, so again multiply by 2 into h1 square. So here with respect to the second component we have to see, so here what will be the thing, it's a difference between the centroid of the L section and the self-centroid of the particular section, okay, individual section, second section. So here it will be y2 minus y bar the whole square. So here the
things will be B length. B is a what length, so here it is 1 into H is 4 cube divided by 12 plus 4 into Y2. So Y2 here it is 3 minus Y bar here it is 1.75 the whole square. Okay, so if you do the calculations, I hope you will get the value as 11.58 centimeter power 4. This is for IX2. Okay, so this will be the value. Now add both the things, 6.58 plus 11.58. So here if you add it, you will get the moment of inertia about IXX. So here it will be, the value is 6.58. We are just adding it total 6.58 plus 11.58. So here we get the value as 18.16 centimeter. Just add it down, 6.58 plus 11.58, you will get 18.16 in terms of centimeter power 4. This is the moment of inertia about IXX axis. Similarly, do it for the IYY axis. So IYY which is equal to IYY in the first component and the moment of inertia and the second component. So first start with the first component. So here the formula similar fashion, if you elaborate it, IGY1 plus A1 into H bar B whole square. So here IGY, here HB cube, it's a rectangle, it's Y, which is HB cube divided by 12, okay, plus area for 1, A1 is a 4 and H which is Y, it is for X, am I right? It is for Y, am I right? So the perpendicular distance will be X1 minus X bar the whole square. So do the simplification. So here the H is 4 and here the H is 1 and B is 4, breadth, length and which is a breadth, right? So H1 into B is equal to 4. So 4 power 3, here we get 12 plus 4 into X1 which is X1, here it is 2. So 2 minus X bar here it is 1.25. So you will get the answer. I hope when you are doing the calculation you will get 7.58 centimeter per 4. Okay, this is IYY1. If you do it for IYY2, then you will get IGY2 plus A2 H bar the whole square. Then you will be getting here BH cube, right? HB cube divided by 12, it is for Y, so HB cube, and here X2 minus X bar the whole square. The similar fashion we have to elaborate it. So here B is 1 and H is 4, right? H is 4 into 1 cube divided by 12 plus 4 into X2 value. Here X2 value is 0.5 minus X bar, here 1.25 the whole square. So here you will get the value 2.58 centimeter per 4. This is for IYY2. Now do the addition so that you will get moment of inertia about YY axis, which is equal to 7.58 plus 2.58. So here you may get the value as 10.16 centimeter per 4. This is IYY. So this is the answer for the moment of inertia in YY axis, right? So after finding it, go to the product of inertia. Product of inertia. Right. So here in the product of inertia, the formula is IXY. IXY, sum of IXY plus sum of A into X dash Y dash. IXY in the sense it is nothing but product of inertia for the each component. So here comes, we have two components, right? This is the first one and this is the second one. So here if I elaborate this formula, I can say it will be IXY plus IXY1 plus, right? Here it will be A1 and X bar, in the sense it is just like a similar fashion. So here difference between the centroid and the self centroid of that component. Okay, so x1 minus x bar into y1 minus y bar. Okay, and move to the second component. Here I product of inertia for the second component. Okay, second component plus a1 into x2 minus x bar into y2 minus y bar. Okay, so here for the rectangle, for rectangle, the product of inertia is equal to 0. If you are having the symmetrical object, that means symmetrical about x-axis or y-axis, then the product of inertia is 0. As well when we are having the rectangle, then semicircle, square, circle, for such kind of things also it is a 0. Only the right angle triangle has the product of inertia, which I can say b square h square divided by 72. So here the two components are a rectangle. So here the product moment of inertia or product of inertia is equal to 0. So both the terms will carry as 0. So here if I substitute a1 is 4 and x1 value is 2, just look into the previous one. Here you will get it. X1 is 2 and minus x bar is 1.25. Okay, and y1, the y1 value is 0.5 minus y bar value, which is 1.75 plus, and again ix2 y2, which is a 0. Okay, so that I just leaving it. So here the second component, so a2 is 4, and then x2 minus x bar already we have taken here. So by looking it, I just going to write h2 minus x bar into y2 minus y bar. Y2, the value is 3 minus, and the y bar answer is 1.75. So just feed it in your calculator, just like this. You will get the answer as minus 7.50 centimeter per 4. Okay, this will be the answer. You get IXY, product of inertia for this particular L section. This will be the answer. The next thing is after completing it, move to the location of principal axis. Location of principal axis. So here the principal axis formula in the introduction part I have given you. Tan 2 theta is equal to minus 2 IXY divided by IXX minus IYY. Okay, this is the formula I have given you. So just substitute tan 2 theta, which is equal to minus 2 into IXY. So here 7.50. What happens? The minus and minus will become positive. So here it will be a positive term. Okay, and then IXX value we have found as 18.16 minus here IYY 10.16. So here if you just do the simplification, here you will get 1.875, right? This is a tan 2 theta. So 2 theta is equal to tan inverse of, when doing the simplification, it will be just like this. Again, if you simplify it, I can say this tan theta, tan inverse of theta is equal to tan inverse of 1.875 divided by 2 it will be. And the theta, we get the answer as 30.96 degree. Okay, this is the major axis. Actually this theta will say is the major axis. If you want to identify the minor axis, then theta value, for that the minor I just going to take as theta 1. So the formula is theta plus 90 degree. Always with respect to theta, if you took the theta 1, it will be theta plus 90 degree. So here it is 30.96 degree. So plus 90, we get somewhat 120 something. Just we will get 120.96 degree as theta 1. Okay, what is next? The last one is our exact part, that means principal moment of inertia, which is I max and I minimum. Now all the data in order to identify the principal moment of inertia is ready. So here principal moment of inertia, I max and I min. First start with I max. The formula is IXX minus IYY divided by 2 plus root of IXX minus IYY divided by 2 the whole square plus IXY the whole square. Okay, this is the formula we need to substitute. For I max it is positive. So just substitute IXX value is 18.16 and YY value is 10.616. Okay, 10.16 divided by 2 plus root of IXX 18.16 minus 10.16 divided by 2 the whole square plus IXY value we calculated, IXY value we just calculated minus 7.50 minus 7.70 minus 7.0 or 70. Okay, so now do the just simplification. Just with the help of the calculator, you get 22.66 centimeter per 4. This is for I max. I minimum it is just easy. Ixx minus Iyy divided by 2 minus instead of plus it is a minus, that is a difference. Okay, then root of Ixx minus Iyy divided by 2 the whole square plus Ixy the whole square. Just do the minus in that particular place. You will just get the value as I minimum 5.66 centimeter power 4. This is the moment of inertia maximum you get, and this is the minimum we get in the I section. After completing all this, we need to specify the axis in the L section. So that is easy part. Result just draw the exact picture. Okay, and somewhere here we have the centroid, am I right? Somewhere here we have the centroid. Somewhere here the centroid is, this is the centroidal axis xx, this is centroidal axis yy. Okay, and in order to specify the first Imax in the sense it says the theta, the inclination says by the theta. Okay, so theta which is 30.96, so approximately if you take it 30 in the sense here we get it right. So approximately the line will be, axis line will be something like this. This is the I max. Okay, and if you just draw the perpendicular line with respect to this I max, then it will be I minimum. Okay, that's what here calculated. Theta 1 is equal to theta plus 90. From this theta value, just we have added 90 degree, we got the theta 1. Theta here it is 30.96 degree, and the theta 1 is 120.96 degree from here. Okay, so just we have plotted the I max and I minimum, which is nothing but principal moment of inertia. So when you are having such questions, just go with the procedure. First identify the location of centroid, then go to the moment of inertia, product of inertia, then location of principal axis. So if you find out all of this, then everything will be ready for identify the principal moment of inertia. So just put the formula, directly substitute it, do the calculation. When you put positive, you will get I max. When you put negative, you will get I minimum. I hope you understood. Thank you so much.